5i. So modulus of that equal to 3. And so the center is 0, 5. So look for which one has 0, 5 as its center, and the radius is 3. So you want one with the center?
Sir?
Yeah.
Since it's 0, 5, isn't the answer B as in boy?
0, 5. Yeah, it should be B. So why did I shade D? What's D? That's 0, negative 5.
Yeah, because there's 2 questions like this.
Oh, yeah, I understand. And I can't even get rid of that. Put a big X right here. Yeah, so sometimes I put Z plus 5i, right? And,
Yes, sir.
and then sometimes I put Z minus 5i. But yeah, we can write it in this form, and the center is 0, 5. So as you rightfully said, yes, it's boy. Nice.
Afternoon, sir.
All right, good afternoon. So we're looking at 2018 paper.
2018.
Yes.
Following,
Do you have a copy of the 2018 paper?
no, sir.
All right.
Z minus 0 plus 5, yes. It has a center 0 and 5 and a radius unit of 3. But sir, how did we say we sketch the circle again?
All right, so I'm sending you the paper right now. So it should take probably about a minute.
Wait, through WhatsApp?
It's a 20 paper. No, I'm sending it in the Zoom chat right here. In the Zoom chat. So we're almost there, almost time for Cape Math.
Yes, sir.
Have you received it?
I don't see anything in my chat.
So you sent it to me privately.
Oh, I sent it. Oh. Asani, check again. I'm going to try again.
Nothing, sir.
Nothing? I don't understand because I sent it now generally.
Sir, to the number 2, sir, you say x squared equals to minus 1 and then you square root that.
All right, so for number 2 right here, it gives us that x squared plus 1. X squared plus 1 is 0. So talk to me. What you said we're going to do?
So you're going to say like x squared equals to minus 1 and then you say the square x will equal to plus and minus the square root of negative 1.
Yeah, so x
So
is
that the square
equal
root
to
of
plus or
negative 1 is
minus.
I.
Plus or minus the square root of negative 1. And the square root of negative 1 is I. So x is plus or minus I.
Yeah.
So that is
Let me just
option
write down
D.
these answers.
That's option D. All right, let me know if you've seen it in the chat. I've sent the 2018 paper. Have you seen it?
I received it.
Yeah, have you received the 2018 paper?
So I'm in the chat. I'm checking the chat, but I don't see anything in my chat, sir.
In the Zoom chat, you don't say anything?
No, sir.
All right. All right. When we finish, what I'll do, I'll just WhatsApp it to you or
Yes,
email
sir.
it to you.
Perfect. That's better.
All right. Good evening, Shane. All right, let's continue. Question 3. So question 3 says, given that z is equal to -1 plus the root 3i, then the exponential form of the complex number is?
Number 1 is boy. Number 2, dog.
All right. So for question 3 now, what we have to notice is that this is in which quadrant?
Quadrant 2.
Minus the second quadrant.
The second quadrant. And how we find the argument in the second quadrant?
It's theta plus pi. Or theta minus pi. One of them.
So yes, in the second quadrant, as I rightfully said, it's theta plus pi. And tell me, why is it theta plus pi? Remember, argument is always the angle between the
In the
positive.
positive real axis and the complex number.
Yes. So it's all of this we want. So that's why it is that right there. So first and foremost, we have to find R, or the modulus of Z. Mod Z, first and foremost, is clearly 2 from all the options. Mod Z is 2.
The exponent
Right.
from RE to the I theta to find the modulus and the argument for you.
And so now all we need now is the argument of Z. Let's just call it arg Z.
The tan inverse of root 3 over 1 over -1.
All right, so remember, arg Z in the second quadrant, as we said, it is pi plus.
Pi plus, yeah, right.
It's going to be pi plus tan inverse. Oh, I don't like how that plus came.
Pi plus tan inverse of minus root 3.
Pi plus tan inverse of minus root 3. What's that? What's tan inverse of minus root 3?
Minus pi by 6.
Minus pi by 6. And so it works out to just be pi minus tan inverse of root 3 is pi by 6?
Pi over 3.
Pi by 3, pi by 3.
Oh,
Pi by 3.
pi by 3. And so pi minus pi by 3, that gives us 2 pi.
2 pi by 3.
2 pi by 3.
So the answer is dog.
So the answer is indeed dog. Nice. Question 4. Question 4 is asking us for the derivative of this right here, this function. So the best way to do this is when you're differentiating a log function, remember that differential of log u is 1 over u times du. So
the ln of
right,
1 over
so we can
x
call
to the
that
1/3.
So call this here u, and so u is equal to, just rewrite
ln
this
of
as
x to the minus 1/3 to the minus
x to the
x to the minus 1/3.
x to the minus 1/3. Very good. So we just need to find du. And so du
So ln
is equal to,
to
what would be the differential of x to the minus 1/3?
minus 1/3
Yeah.
times x to the minus 4/3.
X to the minus 4/3. Very good. And so now we can actually just write down what the derivative of ln this is. So let's call all of this y. Just going to reference this as y. So if that's y, we can write the derivatives of as y prime. Y prime is equal to 1 over u 1 over u. So 1 over x to the minus 1/3 is just x to the 1/3. Agreed?
Yes, sir.
So we have x to the 1/3, 1 over u times du. It's going to be multiplied by minus 1 over 3 times x to the minus 4 over 3.
1 over x to the 1/3.
So when the bases are the same, we'll add the powers, and so it works out to be minus 1/3 of 1/3 plus minus 4/3 is just x to the minus 1. X to the minus 1, as we know it is 1 over x.
Wait. So we say y equals to the ln of 1 over x to the 1/3, right?
Yeah.
And then you reciprocate what's in the bracket. So it's going to be the ln of x to the minus 1/3.
Yes, so we just rewrite this in, instead of having it in the square root form, just write it in this form.
Yeah, when I write it in that form, sir,
Then we find the derivative of u, because the derivative of ln, as we know it, ln of u, the derivative is 1 over u times du.
so it is 1 over x to the minus 1/3, right? And it will multiply by the derivative of x to the minus 1/3.
Yes. And
Okay.
at this point now, the only thing we need to do now is, since the bases are the same, we add the power.
So it's minus 1 over 3x to the 4/3.
All right. Question 5 is a repeat question. And we know
Minus
that
1/3.
question 5, repeat question, that is boy, right? We've been through question 5 multiple times. Agreed?
Negative 1 over 3x, sir. So 4a.
Yes, sir.
Yeah. Oh, yes. Question 4 is minus 1 over 3x. And question 5 is beta. We've done question 5 numerous amount of time.
All right.
Question 6. Question 6 asks for the locus is described. They're asking that the locus of the points described by the complex number z is given by z minus 1 minus 2i
Z
equals
minus
3.
1 plus 2i.
Then they want the locus that describe the circle. First and foremost, we have to write this in a better form. We can write it as z
Set of a
minus,
center
put a bracket,
1 and
plus
2i and the
2i,
radius of 3 units here.
and the radius is 3. So this is the form that we need to write it in. So we can then see that the real part is 1, the imaginary part is 2. And so that's option C. Easy question. Question 7, this is another repeat question where what we did was rationalize it. They gave us the complex number z is equal to 1 over 1 minus I. So we know 1 over 1 minus I. All we have to do is multiply by the conjugate of the denominator, which is 1
1
plus
plus
I
I.
over 1 plus I. In the denominator,
1
what we're
plus
going to end up with is the difference
I.
of 2 squared, which is just 1 squared plus 1
1
squared, which is 2.
minus I squared. So 1 plus 1. It are
And
equal to
so it works out to
a
be,
half plus a half I.
yes, 1 plus I over 2. And that's just a half as a point. And so that's option A.
Half and this.
This is
And half.
actually a repeat question as well.
So it's in the first quadrant.
Yes, it's in the first quadrant.
So 7 is apple.
Yes, nice. All right. Since we're using fruits, apple, number 8. this is a repeat question again. They gave us dy by dx and want d2y by dx squared, the second derivative. So let's find the second derivative. It's d2y by dx squared. This second derivative is given by
2x dy by dx plus y plus 2y.
dy by dx or y prime plus 2y. Nice. And then they gave us at the point 1, 2. So put x as 1 and y as 2.
Y as 2.
So 2 times 1. Then right here want y prime, which is dy by dx. So we'd have to put 2 times 1 times 2, that is 4. So y prime is 4 plus 2 times y, and 2 times y is 2 times 2, which is also 4. So we're getting 8 plus 4, which
Plus
is
4,
12.
12.
Easy, nice and easy.
Nice
Option
and
C.
easy. Not harmful.
All right, that's option C. Hopefully, they're just like this come next week, Monday. Question 9. Question 9, it says the expression I times all of this is equal to. So we have to just expand and simplify what's inside the bracket right here. So we have I times, expand this bracket and it becomes 1 plus 2i
1 plus 2i plus 2
plus I square
I square.
minus, expanding this bracket is the exact same thing. Instead of plus 2i, it's minus 2i plus I square. That's in that bracket. So now when we
The
simplify
I squares them
inside
cancel
now,
out.
the I squares cancel and the 1's cancel.
Plus 2i.
2i
Plus
and
4i.
2i is 4i. Nice. So it works out to be I times 4i.
4i, which is 4i squared. And I
But
squared
I
is
squared
minus
is
1.
negative 1.
It's minus 4.
So it is minus 4. That's option A. Nice. Question 10. Question 10 is asking us to integrate 1 over 9x squared. This, we can always rewrite it as the integral of 1 over 1 plus,
1 plus
instead of saying 9x, let's
3x all square.
say 3x all square. Instead of saying 9x square, we can say 3x all square. And so in order to integrate this, we need the derivative of our u in the numerator. So we can put the derivative of 3x as we know it is 3. So multiply the numerator by 3. And so put a
and
1.
multiply the integral by 1/3 to preserve the function.
Yes, very good. So
So
put a
1/3
1/3 on the outside.
tan inverse of 3x plus c.
So it's just 1 over 3 tan inverse of 3x. Easy question. Nice and easy. So far in 2018, no new question from the
Sir,
first.
what if they replaced the x square part with x over 9?
What if they had replaced?
What if it was the denominator was 1 plus the square of x over 9?
The square
Of x over 9.
Oh, so if it was 1 plus x square over 9?
X over 9 all square.
Or x, let me write down what you're saying. If it was 1 plus x over 9.
Yeah, I square that.
Oh, if it was 1 plus x over 9 all square. All right, so you would then just be x over 9. All right, and so you don't need a differential in the numerator same way. And you put the
differentiate the x over 9, I get 1 over 9.
Yes, so you put 1 over 9 in the numerator, and then you have to divide it back by 1 over 1 over 9, which is 9. That's what you would do.
So that'd be 1 over 9 tan inverse of x over 9 in that case.
it would be 9 times tan inverse of x over 9.
Okay.
All right. Easy question. Question 11. Where's question 11? Question 11 asking us to integrate cosine 5x cos 2x. Repeat question again. This is option C. This is just using the sum of two cosines formula. As we know it, cos A plus cos B is equal to, let's just write it down right here again. Cos A in this case, our A is
Cosine,
8x.
sir. This reminds me of the cosine of A plus B.
Yeah, this is exactly it. Cosine 8x plus cosine 2x. This is the sum of two cos, and that's equal to twice the cosine of half the sum. So it works out to
The
be
two
twice the cosine
cosine
of
A
8x
plus B
plus
over 2
2x divided by 2, which is 5x, times the cosine of 8x minus 2x over 2, which works out to be
sine
3x. Not sine, cosine. And then what they do is divide both sides by 2 to get this solution. Easy question. Not a repeat question. Question 12 is another repeat question. We want the square root of 3 minus 4i. So all we have to do is just
The
look
number
at
11 is what again, sir?
Oh, number 11 is cat.
Number 11, oh.
Cat. Question 12, just look at the option and see which one of them, when you square it, you'll get
It
back
gives
the
you
answer.
3 minus 4i.
So when you square 2 minus I, you'll get 4 minus 4i plus I squared, and I squared is minus 1, and this gives us back the 3 minus 4i. And so that's why it is option C. And that's question 12. Question 13, it is asking us to integrate sec squared over 2 tan x. And so when you're integrating a function where the differential of the denominator is in the numerator, it's ln the denominator. But we can factor out this half. We can always rewrite it as a half the
times the
integral.
ln of the denominator.
Yes. So let's rewrite the function as a half the integral of sec squared over tan x. So that's how we end up with a half ln tan x. A half ln tan x. That's option A. Easy question. So far, everything is repeat question from previous papers. Everything so far. Everything, which is very good. Question 14 asks us to find the principal value of the argument of the complex number minus 2 plus 2i. Now,
The principal value of
the principal value of the argument of the complex number
the tan
minus
inverse
plus
of
2i.
-1 is all right. If I sketch this, 2 and -2 is in the second quadrant.
It's in the
So
second quadrant. Very good. So it's this angle we want, right? So it is pi plus
pi plus
tan
the tan
inverse
inverse of -1,
-1
which is minus pi by 4.
minus pi by 4. And so it is just working out to be pi minus
Pi by
pi
4,
by
which
4.
is 3 pi by 4.
3 pi by 4. So that's option D right there. Easy question. Soft with a capital T. Question 15. Question 15 is asking us, given sec squared is equal to 1 plus tan square x. Find the integral of tan square x over 4. So we have to rewrite to make tan square the subject and realize that tan square is equal to sec square minus 1. So sec square x minus 1. That's what we're integrating now. So we're integrating sec square minus 1. Let's just put the quarter on the inside. And so it is really just now a quarter of, when we integrate sec square, what we get is tan x.
Tan x.
Sec square, we get tan x. Or we integrate 1, we get x.
X.
Minus x. And we're going from 0 to pi. Now, what is the tan of pi?
The tan of pi is minus 1.
Tan of pi is minus 1?
It's 0.
Oh, 0.
Tan of pi is 0. And so, we'll put in that we're getting a quarter of, we'll put in pi, we're getting 0 minus pi, close up that, minus 0, because when we put in 0 right here, we're just going to get 0. So the answer is, why did I put pi over 4? Sorry, pi. So the answer is a quarter of minus pi. That's option A.
Option A.
So every question from module 1 for 2018 were repeat questions. Everything. Let's hope 2020 is just the same. Everything to be repeated.
Which year paper? Which year paper?
This is 2018 paper.
Oh, you gonna send me the paper?
Yeah, I sent it in the chat, but I'm gonna send it again in the chat right here.
Sir, let me see number 15.
Ah, shit.
Sir, could you scroll down a little bit?
All right, so
yes, A.
all right, that's fine.
Yes, sir.
All right. All right, so the 2018 paper, it will be sent in a moment. It's loading. All right, question 16. Question 16 says, for 2n between -1 and 1, we have this summation to evaluate, right?
It's a convergence theory.
Yes, it's convergent, because what they're telling us right here, what is this that they're giving us?
Malcolm.
They're giving us right here the common ratio is between 1 and -1. When the common ratio is between 1 and -1, then they're telling us that it is a convergent series. And so finding the sum from 0 to infinity is the sum to infinity. And the sum to infinity, as we know it, is a over 1 minus r, where a is the first term. So the first term would be 2n to the 0, 2n raised to the 0 power over 1 minus r. The common ratio, 1 minus r, they're telling us that r is 2n. 2n to the 0 is 1, and so it is 1 over 1 minus 2n. And that is option B. Easy question.
Sir, go again. Next, when you plug in 0.
Oh, so they're telling us that we're finding the sum from 0 to infinity, and so that's the sum to infinity that we're finding. Sum to infinity is given by a over 1 minus r. And so the first term is going to be when we plug in r equals 0. And so a is 2n to the 0 power, but 2n to the 0 power is 1. The next thing is that we need a common ratio r, but the common ratio r is given by 2n. So it's 1 over 1 minus 2n. All right, so that's question 16, and that's B. Question 17. Question 17 is asking us for the binomial coefficient of n choose 4. Now, as we said, n choose r is equal to
n factorial
n choose
over
n minus r.
n minus r
And so therefore, n
factorial
choose 4
r factorial.
is also equal to n choose n minus 4.
N choose n minus 4. Yeah.
And so in factorial notation, it is this way, n4 is equal to n minus 4. That's option B. That's option B as well. Very easy question, soft. All right. Question 18. Question 18 says, given that un represents the nth term of a sequence, which of the following converges? Now, there are many ways to determine the convergence of a sequence, but the easiest way to determine which one converges is to look at as un.
When you take the limit to the infinity.
Un need to go to a finite value, L, as n goes to infinity. So un need to go to some finite value as n goes to infinity. That's the easiest way to do it for an MCQ question.
Sir,
Yeah.
but like I just use the the UN plus 1 over UN version.
Yes, that's D'Alembert ratio.
Yeah,
You can use
I
that
just
as well. D'Alembert ratio test. So
yeah, I just look on it and trying to figure out which one of the questions would be like less than 1 and just like plug in. Cause I tried A and C and then I realized C was the answer.
yeah. So with D'Alembert's ratio test, we can use that as well. We can also use convergence theory, and we can also use integration as well and find which one converges, right? That's the integral theory. But let's just use this easy method as un goes to some finite value when n goes to infinity. As n goes to infinity right here, clearly the first one is not going to a finite value. As n goes to infinity right here, what we notice is that we're going to get 2, -2, 2, -2. So for option B, it is alternating between 2 and -2. And so this one is not converging as well. Then we check option C. So when you check in option C, when you apply the limit as n goes to infinity, what we can do right here is divide through the numerator
By
and the
n.
denominator by the highest power of n to get 5 over n minus 3 divided by 2 over n minus 1. And then as you plug in as n goes to infinity, what we realize that is as n goes to infinity, it's going to 3. -3 over -1 is 3. And that's how when n is going to infinity. So that's option C.
Sir,
Question 19.
sir,
Yeah.
if you apply the limit law for A, C, and D, it's gonna be divergent.
Yes. Well, yes. A and
Well,
D are
A,
going to be divergent. A and D. Option B is going to work out. It's going to show that it's
alternating.
alternating. Nice. Question 19. Question 19 asks us to find the interval where root lies. Now, in order to find the interval where the root lies, we need to use IVT.
The IMVT theorem.
Yes, so we use intermediate value theory. And since we know it's between 1 and 2, all we have to do is show that f of 1 is going to be less than 0 and f of 2 is greater than 0. So f of 1 is equal to e to the 1 minus 1. So that's e minus 1, which is greater than 0, because e is 2.7. And then f of 2 is going to be e squared. E squared is about 9 or maybe 8 point something, minus 2 to the 4th power, and 2 to the 4th power is 16. And so this works out to be less than 0. So by IMVT, the root lies between 1 and 2. So that's question 19. Soft, a capital T. All right. Question 20. It says that the sum to infinity of a geometric series is 1 over 1 minus 2x. Now, sum to infinity, first and foremost, sum to infinity
18. Well,
occurs.
sir,
Yeah,
I didn't get 18 and 19. Sorry about that.
18 and 19.
Yes, sir.
Okay, so 18 is cat and 19 is bat.
Okay, thanks.
All right. Now for question 20, when you want the sum to infinity of a geometric series, sum to
geometric.
infinity only occurs when the common ratio r is between 1 and minus 1. So in this case, what we're clearly seeing is that 2x, which is a common ratio, is between 1 and minus 1. And so therefore, x must clearly be between
1 and negative a half and negative a half.
half and negative half. And so that's option D. Very easy question. Soft, a capital T. And that's dog. Question 21. Question 21 says, let AN and SN denote respectively the value of the nth term and the nth partial sum of the series. Find the value of Sn plus 2 minus Sn when calculated on this series. All right, so
Sn the equal to the sum of the first
terms.
term.
Yes, so Sn is always the sum of n terms. So since we're
And
using An to represent the nth term, we can write Sn to be A1 plus everything up to An. So now Sn plus 2 is going to be from A1 up to An plus 2. So it is A1 plus everything
A1 plus A2 plus
An plus An plus 1
yeah,
plus An
A1
plus 2.
A2 plus A plus onwards.
And so therefore, if we're taking the difference now between Sn plus 2 and Sn, the only thing that will remain is An plus 1, An plus 1, and An plus 2. These are the only things that are going to remain.
So An plus 1 and An plus 2 remain.
And so that is option C. Easy question. Soft. Question 22 is a method of difference question. So we want the summation from 1 to n of 1 over r minus 1 over r plus 1. So let's find out the sum of 1 over r first. 1 over r first is going to be, putting r being 1, we get 1 plus a half
plus a half plus a third
plus a third, and we'll continue till we reach 1 over n.
1 over n.
Then we're going to be subtracting. We'll plug in r as 1, we're getting a half.
Plus
then we'll
a
plug
third.
in a third. And then we're going to continue all the way till we reach. We'll put, look at this now, we'll put n. We'll put r as n minus 1.
We'll get 1 over n.
And then we put r as n, we get 1 over n plus 1.
Yeah.
And so when we take the difference, what is going to remain is 1
plus
minus
1 over n. 1 minus 1 over n plus 1.
The halves, yes, because the halves cancel, the thirds cancel, 1 over n cancel, and so we're left with 1 minus 1 over n plus 1. That's the answer. And we can go further to rewrite it as 1 fraction to get n over n plus 1. So we can go further and write it there. That's option D. Easy, soft. All right.
Yes,
Question
dog.
23.
22 a dog.
Yes. Question 23 asks us to find the summation from k equal 1 to n
Oh, I need to.
of k times k plus 1 is given by Sn. And they tell us m is less than n. And so the sum from m plus 1 to n. Now look at this now. Just to refresh our memory, the sum from 1 to n, the sum from 1 to n can be rewritten as the sum from 1 to some other number, let's use m in this case, m, plus
Sum
the
from 1
sum
to m plus the
from
sum.
from m plus 1 to n, right? What this is saying is if we're summing from 1 to 10, we can add from 1 to 4, then plus from 5 to 10. That's still the sum from 1 to 10, right? And so we just need to make the sum of m plus 1 to n the subject. And so from this above, we're seeing that the sum from m plus 1 to n is equal to the sum from 1 to n. So it's the sum from 1 to n minus the sum from 1 to m. Now the sum from 1 to n is given by Sn. And then the sum from 1 to m is given by Sm. So it works out to be Sn minus Sm. So that's option C.
Okay.
Easy question. Soft. Nice. All right. Now question 24. Big repeat question, 1/24. And how I want you to look at this without even working this out, right? Let's say they had asked you for coefficient of x cubed or x squared. First and foremost, all we know is that we're always going to be dividing by n factorial, right? And so if they want the coefficient of x to the 4 in the expansion of cos x, only thing you need to remember it's going to be is 1/4 factorial. But let's say you don't want to look at it that way, work it out. You can always rewrite it by just working it out. F of x is equal to f of
f of
0.
a.
In this case, x is 0, a is 0.
F of
So f
0.
of 0, f of cosine of 0 is 1 plus f prime of
double prime of a. F double prime of 0.
So when we differentiate cos, we get sine
Minus sine.
and yes, minus sine, and the sine of 0 is 0.
0.
So we can just write 0/1.
Over,
right?
you show over 2 factorial, sir?
Over 1, it's f of 0 plus f prime
F
of
prime,
0.
F prime. Oh, yeah,
Yes.
yeah.
Then f double prime now. F double prime is when we differentiate
Negative sine x.
to get minus.
Minus cos x.
Yes, so we get minus cos x. And
Cos of
minus
0
cos
is
of
1.
0 is 1.
So it's
So
minus
it's
1.
minus 1. So it's minus 1 times x squared over 2 factorial, which is 2. Then it's going to be plus 0 again over 3 factorial. And then we get now the plus 1 times x to the 4 over 4 factorial. Now 1/4 factorial works
Factorial
out
is
to
24. So
1/24. And so that's how we
Yeah.
get option D. Easy question. Question 25. Question 25 asks us for the value of the term independent of x. So if we want the value of the term that is going to be independent of x, we want the value of the term that is independent of x, what we need to do is, let's say we have the first term, as you know, it's x squared. We can raise that to the fourth power and times it by
sum from
1
r
over
equals 0 to infinity of
to the 8th power.
a to the n.
All right. So this is what we're going to have, right? We need to have x to the 8 in the
n
numerator.
minus r, x to the r.
All right, so that's the formula indeed. But as we were saying, what we just need to have is x to the 8 in the numerator and x to the 8 in the denominator, right? So in order to have x to the 8 in the numerator and x to the 8 in the denominator, the coefficient then, which is n choose r, n in this case is 12, and it's 12 choose 8. That's the coefficient, 12 choose 8, right? So now we can go ahead and find.
So it's 12 choose.
So 12 choose 8 is going to be the coefficient.
Wait, why would say 8, sir?
Why would say 8? Because remember what the formula is. So let me write down what the formula is. It is n choose r
of a to the n minus r.
N minus r times b to the r, right? Notice that r and r right here is the same.
Sir? How is r 4?
R is 8 in this case. Why? Where did I get this 4 from?
Yes, sir.
Now I'm going to get to that now. Right? So let's get to why that it is 4. It is 4 because as we said, remember we said earlier that n choose r, remember we said n choose r is equal to n choose n minus r. N choose n minus r. And so even though we know that it is 12 choose 8, if you put n as 12 and r as 8, then 12 choose 8 must be equal to 12 choose 4. 12 choose 8 is equal to 12 choose 4. The option that they have is 12 choose 4. And so that's why it's 12 choose 4. So we have to remember this theory right here. N choose r is equal to n choose n minus r. And that's option A. So far, everything repeat question. There's nothing new from 2018 so far. All right. Which of the following statement is true? Option A cannot be true. The sum from 1 to n of r squared, we know that this is a formula given as n times n plus 1 times 2n plus 1 over 6. And it's clearly not going to be equal to 2 times the sum from 1 to n. So this one is out. Option B is not going to be true because the sum from 1 to n of r squared, the sum from 1 to n of r squared, as we know it is n times n plus 1 times 2n plus 1 over 6. And this is not going to be equal to, it's not going to be equal to the sum from 1 to n of r all square. It's pretty much, they're trying to say that it's equal to the sum from 1 to n, as we know it is n times n plus 1 over 2. Though this will be on the formula sheet as well, n times n plus 1 over 2 all square. Now these two are not equal. And so option B is also out. Option C now. Now option C, this is true. The sum from 1 to n of 2. This part is the sum from 1 to n of 2 plus the sum from 1 to n of r squared. So break up this in 2 parts. Break it up as the sum from 1 to n of 2 plus the sum from 1 to n of r squared.
The sum from 1 to 2 is 2n.
the sum from 1 to n of 2 is 2n because we're adding 2n times. And so that's how we get 2n plus the sum from 1 to n of r squared. So that's why it's option C. So that's option C. Very easy question.
C.
All right. Question 7, another repeat question that we've looked at. 1 over
Sir,
36.
number 25 and 27, I have to go work on those questions.
25 and 27.
Yes, sir.
Also, questions that involve using binomial expansions.
And finding the constant, the term independent
Of x. All
of
right.
x.
So 27 is repeat. We know that's A. We do this question every week. Question 27. Question 28. All right. So for question 28, we want to find the sum of the infinite geometric series 180 minus 60 plus 20. The best way to do this is to separate it as two different geometric series. And so we group the positive terms as one geometric series. So it is 180 plus 20 plus continue. That's 1. Let's call that one S1. S2 is going to be minus 60 minus, let's see, minus 60, what would come here? Divide by 3 would be minus 20 over 3. Minus something, and we continue. All right, so now that we've broken it as two different infinite geometric series.
Let us divide through by minus 3.
Repeat.
Let us divide through by minus 3.
I divided through by 3. Because anyway, it's going to be negative, right? Because this is positive. This is positive. So the first term is positive, the third term is positive, so the fifth term is going to be positive as well. Now the second term is negative, the fourth term is negative, then the sixth term is going to be negative, and so forth. So what I'm doing is I'm calling the sum of the positive terms S1 and the sum of the negative terms S2. And so therefore, what I'm saying then is the actual sum right here that we want to find S. S is equal to S1 plus S2. Agreed?
Mm-hmm.
Now I can find what is S1. S1 as we can see is the sum to infinity of A over 1 minus R, which is 180 over 1 minus R, which is 1 minus 20 over 180 is 1 over 9, plus S2. S2 is just A. A is minus 60 over 1 minus R, which is 1 minus 1 over 9.
Huh?
And so, yes. Yes, go ahead.
Go back there again, sir. Wait, sir.
All right, so I was saying that
the denominator.
The denominator, how I get these 1 over 9?
Yes, sir.
1 over 9 is a common ratio for each of them. So 20 divided by 180.
1 over 9.
All right, so that's how I get the first 1 over 9. The second 1 over 9 is 20 over 3 divided by 60.
Oh, 1 over 9.
All right, so that's how I get both those 1 over 9. So the common ratio for both of them is 1 over 9. So now I can add the sum. Just put that in a calculator. 180 divided by 8 over 9 plus minus 60 for 1 over 9. That's 135. Calculator's job right there. Option C. Easy question. Soft. Question 29. It says, let's find the values of x for which the expansion is valid. So the expansion is going to be valid when is this expansion valid?
When who do I do this question? I forgot to do this one.
All right, so no, never mind. So first thing we have to do is look at the denominator. And the denominator we can write, we're going to use binomial expansion theory, the extension of it. We can factor out 100 and write it as 1 minus a half x
minus half x
square root x.
Oh, right. Yeah.
Right? And then what did we learn? We learned that
This
this
is equal to
extension is valid only when a half x is between 1 and negative
1 and negative 1.
That's the only time that expansion is valid. And so it is valid when x is between 2 and
minus 2.
minus 2. So that's how we do that question. Easy, soft. That's option B. All right, so it seems that you have to refresh your mind with binomial theories. All right, question 30. Question 30 is linear interpolation. And to use linear interpolation, all we have to do is remember the formula. And so our root alpha is going to be equal to A times the modulus of f of b. So in this case, our A is 0.
No, 0 times
f of 0.8.
Yes, sir.
Plus 0.8
times
f of 0 times f of 0 over f of 0, modulus of f of 0 plus f of 0.8.
Plus the modulus of f of 8.
All you have to use now is our calculator. Just put this in our calculator. So we're going to put this in our calculator and it's going to work out to be 0.4555. Big repeat question again. So 2018 so far, every question repeat. No new questions so far. Question 31. Question 31 is saying M is equal to this. Then what is the first row of the cofactor matrix? So the cofactor
1 times 4, 1, 5, and 6.
Yes, so it's going to be 1 times 4, 1, 5, 6. Then it's going to be minus 1.
Minus 3.
Where you get minus 3 from? You're not finding the determinant, you know. You're finding the cofactor elements for the cofactor matrix. So the only thing you need on the outside is the signs. Plus, minus, plus.
Minus 1, 3, 0, and 6.
1, 3, 0, and 6, right? And then we need plus 1.
Plus negative 2.
Yes.
4, 0, and 5.
Very good. So this one works out to be 24 minus 5 is 19. This one works out to be 6 minus 0. Wait. This second one is not right. This should be cross minus 2106. This should be minus 2106. minus 2
minus 2, 1, 0, 6.
106. And
Yes, sir,
that
that's what I
works
said.
out. That's where it works out to be minus 12. And then the minus 12, let it become positive 12.
Positive.
Now this works out to be
button what says cat.
minus 10. So the option is option C. That's question 31. Question 32, we do this every week. We know that's 124. Find the determinant of this 3 by 3. This is an every week question. So you say every week question. Let's say this come back in 2020. You just put soft, the capital T.
The
Every week
determinant
question.
of that.
That's 124. Every
Alright.
week question. Here's another every week question. It says 2 coins and a die with faces numbered 1 to 6. Yeah.
Work it out. Work out that question. 33. No, 33, man.
33? Yeah, we're going to work 33.
Yeah, work it out. Okay.
So it says 2 coins and a die with faces numbered 1 to 6 are thrown together once. Assuming that the die and the coins are fair, find the probability of obtaining 2 heads and a number less than 4. So there are 3 events taking place, and we want the probability that all 3 events occur together. So we want the probability of getting a head on the first die, a head on the second die, and we also want to get some number n that is less than 4. So we want all of these things to occur. So we use multiplicative rule, and so it's equal to the probability of getting head on the first one times the probability of getting head on the second one times the probability of getting a number less than 4 on the die. I'm not going to write n less than 4 right here. Just for space, I'm going to write n4. n4 means n less than 4. Now the probability of getting a head is a half, because there's only one way of getting a head. Repeat.
Why half again?
The probability of getting a head, because remember the probability of any event A, is equal to the number of times A occur over the total possibility. Number of times A occur number of times A occurs divided by total possibilities. Now the total possibility is 2. You only can get head or tail. Agreed?
Yes, sir.
On a coin, the total possibility is head or tail. So that's 2. Now the only way you can get head out of 2 options must be 1. So it's only a half a chance of getting a head and half a chance of getting a tail. So the probability of head is a half. Probability of another head is a half. Times number, we need to get a number that is less than 4. Now, how much number out there that is less than 4? 1, 2, and 3. So that is 3. Now, how many numbers are there on a dice? 6.
6.
So it's a half times 3 over 6. All of that works out to be 1 over 8. So that's an everyday paper question as well. Every week that question repeat. Every year. It should be on 2020. All right. Question 34. Question 34 says, given that y equals 0 and x equals 0, find the general solution of the differential equation. So to find the general solution of the differential equation, all we need to do is
auxiliary equation.
Solve the auxiliary equation first. So I like to use u. So that's u squared plus 6u plus 9 equals 0. And so that from the auxiliary equation, I'm clearly going to be getting that u is equal to minus 3 repeated.
Repeated.
Yeah.
So the roots are real and equal then.
Real and equal, yes. So when your roots are real and equal, then the
AX
general
plus
solution
B
is y
times
is equal to, it's equal to e to the minus ax, in this case is u, so it's going to be equal e to the minus 3x
minus 3x times
times
AX
a
plus
plus
B.
bx. But this is not the final solution. They want the specific solution because they told us at the point where x is 0 and y is 0. So let's plug in when x is 0 and when y is 0. What
So
happens?
shouldn't it be AX plus B?
A plus bx, ax plus b is the same thing. A plus bx and ax plus b is the same thing. Only thing I did, imagine if I write it as bx plus a. All I did is just change the constants. So ax plus b and a plus bx is the same thing, all right? It's the very same thing. Very same thing. So don't let this confuse you. It's the same thing. Why is it the same thing? Think about it this way. Mx plus c. That's the general equation of a line, right? Y equal mx plus c. Agreed? Mx plus c. M would be the gradient and c is the y-intercept, right? Agreed?
Yes, sir.
So what if I say c plus mx?
Not wrong.
Not wrong, right? So it's the same thing. That's my point. So now we just plug in x as 0 and y as 0. So we're going to get 0 is equal to, first and foremost, e to the 0 is 1. And then we have a plus b times 0 is 0. And so we're getting that the constant a is equal to 0. So the constant a is equal to 0. So now we can write the final solution. Y is equal to e to the minus 3x times bx times bx. So that is option B, bx times e to the minus 3x.
Okay.
Easy. Oh. Question 35. Question 35 says, if marbles are chosen without replacement from a bag of 10 blue and 5 red, then the probability of getting red marble followed by 2 blue. So they want the probability of getting red marble, then blue, then blue. That is always equal to the probability of red times the
probability of blue times the probability of blue.
Very good. Now the probability of red.
Probability of getting a red is 5 over 15.
Very good. After we choose the first marble, we only have 14 marble left. And so then we have 10 blue marble out of 14. Then after we choose another marble, then we have 13 marble left. And we'd have taken a blue marble, so 9 left. So that's the probability of getting red, blue, blue. It is 5 over 15 times 10 over 14 times 9 over 13.
All right.
Easy question. So, question 36. Question 36 says, a school debating team comprises of 3 teachers, 3 boys, 3 girls, and it's to be chosen from 5 teachers, 4 boys, and 6 girls. So let's find the number of ways to choose this team. So we're choosing, they said that we're choosing 3 boys from 4 boys times we're choosing 3 teachers from 5 times we're choosing 3 girls from 6. All of this works out to be, when you multiply them, I guarantee you it is 800. So you put those in a calculator. 4 choose 3 times 5 choose 3 times 6 choose 3. You're going to get 800. Question 37. It's asking for the cofactor of the element of 3. So all you have to do is cross out the row and the column.
Yes, so
1405.
positive, negative, positive, negative. So negative of the determinant 1, 4, 0, and 5.
5. Yes, because the sign of the cofactor sign of 3 is going to be negative. All right, so that's B. Easy question. Question 38. Question 38 says the number of possible values of x which satisfy the simultaneous equation. Now, first and foremost, what I want you to do is observe this. 2x plus 3y plus 3z, 4x plus 6y plus 4z, 6x plus 9y plus 6z. They are multiples of each other. So if I were to multiply
except for equation 3.
If I multiply first equation 1 by 2, I get the second one. And if I multiply the first equation by 3, let's do that now. Let's multiply the first equation by 3. Multiplying the first equation by 3, what we should get is 6x plus 9y plus 6z is equal to 3 times negative 5 is negative 15. Now look at this now. This question I tell you says 6x plus 9y plus 6z are negative 15. So if this and this, these two shouldn't give you the same thing as negative 25. So the system is inconsistent. From this result, we can see that the system is inconsistent. So the system is inconsistent. And what do we know about inconsistent systems? They have no solution. System is inconsistent. Inconsistent. And so it has no solution. Now, let's say you did not know that from these two results, the system is inconsistent. Well, from right here, when you multiply it by 3, you have 6x plus 9y plus 6z is negative 15. I have 6x plus 9y plus 6z is negative 25. What you could then do is say, let's add these two equations. If you were to add these two equations, well, let's not add, let's subtract them. If you were to subtract these two equations, 6x minus 6x give me 0. 9y minus 9y give me 0. 6z minus 6z give me 0. So I have 0 plus 0 plus 0 would be equal to negative 25 minus negative 15. That works out to be negative 10. Now 0 plus 0 plus 0 can't give me negative 10. And so there is no solution. So that's an alternate method of doing it. All right. Another method of doing it would be to row reduce and show that when you row reduce the matrix, you're going to end up with something like 0, 0, 0, augment some number r. That's when you use row reduction.
And if you replace r with 0, sir, that's infinitely many solutions?
Infinitely many solutions. All right, so that's question 38. Easy. Question 39, the easiest question on the paper. It says AB is J, BC is K, CD is L, ABC is P, BCD is Q, and find the product of ABCD. Now the product of ABCD, you can just break it up as ABC
times B.
ABCD can be broken up as, there are 3 ways you can break it up. You can break it up
AB
as
times CD.
Yes, so
JL.
in this case, we're going to break it up as ABC times D. But then ABC, they told us that ABC is P.
P.
So it works out to be P times D. Imagine this is a CAPE question. Whoa, easy, soft. Nothing to that question. That's 39. And they say that's a CAPE question. Easy.
Ah,
Question 40. It says a suitable integrating factor for the solution of the differential equation. So to find integrating factor, right, this is what we need to integrate. E to the integral of 2 over x dx. That's to find the integrating factor. We integrate e to the integral of 2 over x. So what we're going to get is e to the 2 ln x. And e to the 2 ln x, that works out to be e to the ln x squared. And this works out to just be x squared. Easy question, soft, with a capital T.
yep.
All right. Question 41. Question 41 is asking us to find the general solution of the differential equation dy by dx, and it's equal to y over x. So there are two ways we can do this, but let's just do it by grouping y's on one side and x on one side. So from this, we can bring dx up here. So what we're going to get is that from this, we can write it as 1 over y dy is equal to, this looks like 1 over x dx. Then we can integrate both sides now. So we're going to then integrate both sides to get the integral of 1 over y is ln y. That's equal to the integral of 1 over x is ln x. Plus, of course, some constant c. Instead of saying c, we're going to say ln a. ln a is still a constant c. And so now what we're getting then is that ln y is equal to the ln of
Ax.
ln of ax. And so what we're saying is y is equal to ax.
Ax.
So y is equal to
All I
ax.
have to do is raise e to take e on both sides, and the ln them cancel.
Yeah, or you could just say ln cancel on both sides. If a equal b, then ln a must equal ln b. So the logs cancel either way. Even without raising it to e power or doing it by that way. You can just say the logs cancel on both sides. All right, question 42. Big repeat question. They ask for the probability of L occurring given that K occurs. So
the probability of L given K is the probability of L intersect K divided by the probability of K.
very good. So the probability of L given K is equal to the probability of L intersect K, which is 0.15, divided by the probability of K. K is all of this. This is K, all of this, which is 0.6. 0.15 over 0.6 is a quarter. Easy, soft, nice. Now, right here, they say that Chad, Matthew, Josh, Paul, Tiffany are traveling in a 5-seater car with 3 persons in the back and 2 persons in the front. All right, so let's just set up our 5-seater. So this is seat on the left, driver's seat. Then we have 3 persons can always sit in the back, right? 3 persons can sit in the back. Let's hear what they say now. They say each person occupies a seat and the number of different ways they can sit in the car if Tiffany sits in the back and Josh drives. So this is Josh's seat. Josh is the driver. So Josh take this seat, right? Tiffany cannot sit at the front. So since Tiffany cannot sit at the front, then 3 persons can occupy this spot, any one of the 3, right? Now, let's say we choose 1 person here now, right? So there are 3 persons left. So
three
any one of the 3 can go here, Then any one of the two can go here. Then the last person left sit there.
That's 3
So-
factorial.
So this is now 3 times 3 times 2 times 1. That's what we have. So it is Josh, which is 1, times 3 times 3 times 2 times 1. That works out to be 18. So 3 factorial times 3 is 18. Option A. Easy question. So Josh has to drive and Tiffany have to sit in the back. So it's only 3 right here because Tiffany cannot sit right here. T. Tiffany and Josh, they don't like to sit side by side, and so Tiffany cannot sit here. So X. Tiffany cannot go right here. Tiffany is not going to sit beside Josh. All right. So that's option A. Question 44, it asks to find the general solution of this differential equation. So first thing, let's find the auxiliary, let's solve the auxiliary equation for it. That would be u squared minus 3u. Repeat?
I need to look back on the second order one.
Yes, so this one is just u squared minus 3u. And so solving this, we get u equals 0 or u equals 3. U equals 0 or u equals 3. So the general solution,
So the roots them real and distinct.
real and distinct. So it's y is equal ae to the 0x plus be to the 3x. be to the 3x. And now ae to the 0x, well, that's just 1.
Oh, non-homogeneous second order.
And that's just 1 plus be to the 3x. Well, that's just a, sorry, not e to the 0 is 1. So that's just a plus be to the 3x. In this case, the constant they use are C1 and C2. And so it's just options.
So C2 plus C1 times e to the 3x, yeah.
Yeah, that's what they do. So that's option C. Finally, this question, it asks us the matrix A represents a system of linear equations that undergo some elementary row operation.
No solution.
No solution, and that's because the last row we have 0x plus 0y plus 0z equal 2. Now we cannot have nothing plus nothing plus nothing and get 2, right? That's not possible. If that was the case, everyone get 1 in math, right? So that is beta is the answer. Easy.
And if the 2 was replaced with a 0, then it'd be infinitely many
Infinitely many
solutions.
solution.
And if
Yes.
one of the zeros was supposed to be replaced with like a 2, then it would have been a unique solution.
Unique solution.
All
All right. Now, finally, let's start 2019, which is going to be the last paper before we gear up for the exam. So give me a second. I'm opening now the 2019 paper.
No.